The next important chapter is testing. Testing is an important attribute or important, you can say the concept in a software development model. So we have a separate field for testing. It's called as software testing, which plays an immense role in any kind of software development model. Either it might be iterative or waterfall model. So there plays a small role of testing everywhere. So although in the recent field of industries, the agile model of software development, testing is considered as a parallel way of development where people do their testing and develop together. So it doesn't happen in a sequential order, it always happens in a parallel order. So it's a really good habit to write your tests when we develop our own piece of code for any kind of applications. So Python has a really good support for the framework, lot of framework for unit test, or you can enhance those unit test frameworks to do any kind of operation, whether it could be integration testing, or it could be end-to-end testing, could be a front-end testing. We name it, you can use and apply unit testing framework in any of those. But let's start with the simple framework, that's a unit test framework in Python, and we will just look into the gist of it, how to execute and how exactly it plays. We play around with it. So basically, a Python unit test framework is kind of a version derived from the JUnit testing framework of Java, and it supports a test automation, and it has a setup and tear down concepts. So basically, setup and tear down are nothing but when we have a test case, we need to run some prerequisite setup before our test case should be executed. That's called as setup. And once the test case has been executed, we need to delete all the paths it has covered. That means all the traces it has done. That's called as tear down. And it does support all of them, the unit test, with the concept called as test fixtures. And it does provide test aggregation, like you don't have to worry about picking those tests. So there are attributes that you need to follow, and the framework takes care of what to execute, with just few attributes you need to specify while running the test. And yeah, so the unit test has few important concepts. Those are, as already we mentioned, about the setup, tear down, all those things. They're called as test fixtures, and the test case is the main execution part of the test case, and test suite itself is bundle. So basically, you can look into this particular gist or the script as a test suite, or you can have multiple classes combined and make it as a test suite. So this is nothing but it will have a lot of modules inside, a lot of methods inside that, test methods, and this will have the class and a lot of modules combine and make a particular test suite having n number of tests, and you can build your own framework in that particular test suite. And the test runner is nothing but the runner which is used to execute and pick and execute those tests. So that is provided by the unit testing framework. So basically, the thing is that since we have a test runner, we will not be able to execute this. It would not give you any output, since we need the test runner or the module to execute that. So sorry that. So I'm gonna minimize that. So let's clear off everything. So I'm in the test folder. So basically, whatever the repo we have cloned, there's a folder called as scripts, where we will be putting all the scripts which could not be run in the Jupyter, and some of them it could also be run in the Jupyter, so that you can test it out, check it out from the same exact, sorry. Python lectures. Yeah, this is a repo that we cloned before to get that. So you'll be able to find the same scripts over here also. So to run the tests, we already have those tests over here, so in the test folder. So I'm going to start with the unit testing. So this is, let's explain a little bit about it. So we basically import unit test, so which is already present in the Python. So we don't have to download this package using pip or any, so it comes bundled. And say so let's say we have one test function. So this, we need to test this particular function now. So what we do is so we have to inherit this particular test case, unit test dot test case, any class which we used to write in our test scenarios or in fixtures. This has to come, I mean we have to this has to be a subclass of unit test dot test case. So then we write one test method, and this is nothing but just we call it as test. And so if we just execute this particular test, we would get so what we have done is we have, so these are the frameworks, these are the methods which come in the unit test. So this, you don't have to worry about say writing an if statement and saying if this matches this, this has passed. Nothing, you don't have to worry about this. So this handles in higher level. You just have to call if it's an equal if it's an equal operation you want to perform, comparison you want to perform, you call assert equal. If it's an boolean operation, there is assert true, assert false, on any kind of things, assert in, all those kinds of things. So right now we want to do assert on equal operation. So this particular function will increment by 1. So we call this 3, and we say if it's equal to 4, say that this test case has passed. That means this function has exactly done what we wanted to do. So we can run this and see. So how we run is, if you want to run this particular so in this particular file we have 2 test classes, and we have 1, 2, 3 and 4 tests. This is one test, and these are other 3 tests, and these are called as fixtures. The fixtures actually run just before each and every test gets executed. So the fixture setup fixture executes before the test scenario gets executed. So if there was a one more teardown fixture, that would get executed after each and every test execute. So it's not that setup executes one per class, it executes for each method. It iterates, it executes setup, then it executes the test method, and then again it executes the setup, and then it again. So that's a way unit test performs the fixtures work. So we can actually debug this if that works exactly how we wanted. So since there are 4 tests, so if you want to run all the tests together, what you do is you just write python 3 -m unit test, and say the method module name is unit underscore testing. That's a file name, unit underscore testing. You just run it. So it would say ran 4 tests and all are okay. So if you want more detailed, you just write -v. It would give which particular method has executed. So it says this my test one has executed, and there is a test string methods. That's this test string methods. There are 3 test methods that was executed. So, and also you can do a lot of other stuff. So for example, I have run the entire test class here, I mean test module here. If you want to run only the my test, just copy this and you say you want to run only this. So then it runs only that particular test, and it says it ran 1 test and it was successful. So if you want to break any of the tests, let's make this as a 5. It's basically a false. Let's not edit this. This is always a constant. Let's say that we edit our function, test function. So test function is basically we are going to test this particular function. So we edit those, and when we run this, it's going to give an error saying that 5 is not equal to 4. That means our function did not do what we wanted, and it's an assert error. So it says 1 failure. So, and also you can do a lot of things with that. You can basically have a reporting of this unit test. You can put into a file and put into an XML or file, and then you can use it to show in any of the dashboards. So you can do a lot of other things. If you want more details about more operation which does in the unit testing, you check out the documentation. So this is the gist we have given how the unit testing framework works in Python. And so this we'll also see that we'll also debug this. So I have written a print statement. So what should happen is it should run the setup, then it should execute this, and then it again should run the setup. So it should print out all those in a sequential manner. So let's run this. So now, as you can see, this has failed. But these three tests, if you see the setup, it has print, and then it has gone to test 2, and then it has set up print that, and then it has got to the test scenario. So the test setup will be run every time as a test fixture. So, and one more thing to observe here is we have the test 2 executed first, and test 3 executed next, and test 1 executed. So it means that it doesn't execute sequentially. There is one particular attribute which it follows to execute. So right now it is a alphabetical order. So that whatever name you have specified here, so it follows that. So it's I, S, and U is the order of alphabetical. That's how it's going to execute. So you can tweak all these mechanism and write higher level unit test framework, but this is how the default testing framework in the unit test works. Okay. So that's about the unit testing framework, and it's like the pretty basic level. There are a lot of other frameworks. There is Nose2, Nosetest, there is PyTest. So PyTest and Nose are pretty widely used, and there is a unit test 2 version which is used, which has a backward compatibility, so people use that. And the unit test, the PyTest and Nosetest are widely used testing frameworks because it removes a lot of boilerplates that you have to write in the unit testing framework. It makes it pretty simple to read and write the test cases. So let's compare the same thing. You won't be able to run this again in the Jupyter. So we have a Nosetest module as well. So we'll just try to look into that. So one more thing to notice in the node test is node test actually, you can see the documentation, is that it inherits from the unit testing framework. So it has all the features that it has. So basically it will have every feature it has in the unit test, and also it provides its own methods and its own what do you say, the properties, decorators, all those stuffs, which makes it pretty easy to write the test case. So basically, thing to observe is that, as we had seen here in the unit test, we had to inherit the unit test dot test case. That's not the case in the Nose. So Nose, you just write any task class with the name which follows test and anything. So it has to have a test name. So otherwise, our Nose runner would not be picking up a test case. And same thing with the other methods also. So we have the same test setup and teardown, and we have test methods over here, and this is a method to test. So these are test methods, and also they have to start with the test underscore. That's because our Nose runner picks up the tests which are named in such a way. And this is a simple test here. Over here we are calling our multiply function and checking is the multiply function proper and asserting it. So if you run it over here, so the important thing to notice here, we have to install pip we have to install the Nose to run, because it doesn't come with the Python. So we will install Nose like this. I guess I already have a Nose installed, right? So now if you want to run the Nose, it's a similar way. So we say Python -m, just like the -m unit test. You have -m Nose, and then just say dot. So it's basically going to pick up all the tests, including the unit testing. So this is how the Nose test runner works. It's going to pick up everything which matches its way of writing. So since unit test is a subset of that, it had picked up unit test. So let's reject the unit test and let's pick only our nose test part. So it had two tests. It had run two tests, and important thing to observe is that let's make okay. Okay, by default it doesn't print out the statement, so I think we got to go hyphen hyphen no capture. Yeah. Yes. So when we do a no capture, it's going to print out the print statement as well. So right now, as you can see, setup has run here. After that, test method has run here. After that, a teardown has run. Again, the setup will run, and then test and the teardown. So still we have only one setup and teardown. It will run for both the tests. So now what happens if I remove the test from here? Okay, let's remove the test from here. Yeah. So if you don't have this test in the method, it's not going to pick up. So you might have to explicitly say it to run. So the explicitly saying it to run is by specifying nose test package name and then test name and then your test method name. So, or still it doesn't run. So we have to have the test embedded in that, so that this is a boilerplate. Sorry, this is a decorator, and I mean this is standard we have to follow to run the test. Now again it has okay. So now if you see, it will run that, and if you give the name, it's going to run that particular test. Okay, never mind. I'm not sure why it's not working, but this is how the nose test works. It removes a lot of boilerplates from the unit testing framework. So this looks quite similar to the nose test unit testing, but it has a lot of advantage. So PyTest we haven't covered here, but PyTest is a one project which is like worth looking into, and we should do some exploration which framework suits our needs. Although most of them look similar, there will be some difference that we will be needing in the long run. So to conclude, testing is like really important part of programming, and it will be a part of the development and software development process. So it will be clubbed with that. So this is one part of the program or one part of the development. We cannot remove it. So it's an important attribute of Python programming as well. So yeah, that's all about testing in Python for